start anyway. There we go, we're recording. All right, so we're just answering the question that was asked at 12:10. And so here's a reaction vessel. This would be with calcium carbonate marble chips. So you would have acid in there as well. This is generating carbon dioxide, okay? And then what you would have is you would have the gas bubbling through, and then this liquid over here would be lime water, which is calcium hydroxide, but it's commonly known as lime water. And that would go from colorless to milky white, cloudy white, okay? All right, colorless to milky white, cloudy white, all right? So your test, what you'd have to do is you'd have to do the diagrams. You'd have to say what the chemical is that you need to have in order to test for that gas. You would need to be able to say what the color change is, including the colors that you have before and after. And you basically say that if you are going to, if you do predict that, or if you do observe that whatever gas is there is happening. So that is called a positive test. So if you've got a positive test for carbon dioxide, it'll be bubble it through lime water, color changes from colorless to milky, cloudy white, and that tells you that there is carbon dioxide present, and then you would just label the diagram like that, okay? Because I didn't press record earlier, this would be the test that you would have for oxygen, okay? It's a glowing splint. So this is a glowing splint, and you would place it inside the test tube of oxygen, and the positive test would be that it would relight, okay? Glowing splint. I keep on getting that wrong on the camera because I'm trying to focus. Glowing splint. So this would be a splint, it would be glowing, and then what you would do is you would insert it into the test tube and it would relight. Okay, so that would be a positive test for oxygen. So this would be for hydrogen, okay? And what you would have is you would have a lighted splint, okay? A lighted splint. So that would be the chemical test. And then what you would expect to have is colorless water droplets form on the inside of the test tube because it's a combustion reaction, so the hydrogen forms water. And you would get an explosion, okay? That's the observation, right? Explosion, you could say squeaky pop, but that is the observation. It is not a squeaky pop chemical test, all right? Okay, if you say it's a squeaky pop test, you won't get the marks in an exam. Okay, Jana has asked a good question. Can you please explain the way to test for ammonia in an understandable way? Okay, so let's remind ourselves what the ammonia test is. Thank you, Omar. Good afternoon. Right, you should be seeing the YouTube clip that I recommended to you, okay? So it is a bit stuttery because we've got downloading at the same time, so I'm just going to pause it. And so the first bit is, I believe, let's just have a look. So you start off with highly soluble, so the flask is filled with highly soluble alkaline ammonia gas. So you see this liquid over here, this is a purple liquid. This is, I believe it's universal indicator. And that's what happens. And it starts off as green, and when the, oh, hang on a second. Wait. Let's just see, let's just watch the video. There we go. Right. So the fountain experiment, here we go, this is going to be factor. It dissolves the water, causing a reduction in pressure that draws more water. Okay, that's fine. It takes place in a special apparatus. It's an upside down round bottom flask. Okay, so you have a jet. There we go. All right, okay, so This liquid over here, let me just pause it here. This liquid over here is liquid ammonia. They called it 880 ammonia, but it's actually ammonia gas that's being dissolved in water. Okay, and when you heat it, you can vaporize that ammonia and it forms a gas. Okay, now when you heat that ammonia solution, that ammonia dissolved in water, you turn the microphone off. Everyone's got their microphone. Thank you. So when you heat that, you'll also get water evaporating as well. So you've got ammonia gas coming out, and you've got water coming out. So the potassium hydroxide removes the water, so that you just have a jet of ammonia coming through. And just go back to the presentation. Here we go.
That
Right. Okay, good. So you can see at the bottom what they've done is they've got this ammonia gas going upwards, and the reason why they've got the ammonia gas jetting upwards is because ammonia is lighter than air, so it will float upwards. Okay, and you can see over here that it looks like a feather, it looks like a leaf. It says test the bottom with damp indicator paper, which will go purple. Okay, so the chemical test for ammonia is use damp indicator paper, and the observation that you will see is that the indicator paper turns from green to purple. Okay, Kathy has just asked a question. Thank you very much. That's at 12:20. Right. Okay, Kathy, your question is: there's two ways to test for carbon dioxide beside the lime water one. What is the other one? I think the lime water one is the one that we teach. Oh, you're talking about bicarbonate solution. Okay, so there is a solution that can be used. Let me just maybe Google that for you. Okay, but it's bicarbonate. So if we go back to this bicarbonate indicator, I'm going to call it hydrogen carbonate because we actually have the page saying hydrogen carbonate indicator, and on the left hand side you can actually see there's an arrow. It says increasing carbon dioxide in indicator, and on the right hand side you can see decreasing carbon dioxide in the indicator. Now this is not the same. This is not the same as universal indicator. This is a different liquid. Okay. And this is used in biology. You can actually use it to study water plants. And if there's lots of carbon dioxide that's dissolved in the water, that means that the plants that are inside the water have lots of carbon dioxide that they can absorb for photosynthesis. And if they don't, then that means that they've used up that carbon dioxide through photosynthesis. So the colors allow us to monitor how well photosynthesis is taking place. Okay, I hope that answers your question. Okay, there's no question. Right, okay, Salma, thank you. A little bit of chemistry at last, 10 minutes afterwards. Right, so Salma asks, can you please explain the test for sulfur dioxide? Okay, so let me bring that up. Right, so that was asked at 12:30. Let's present a window. There we go. Here we go. Right. So you should now be seeing chemical test for sulfur dioxide. Now this was the link that I sent through the classroom. Okay. So this was on the quiz. So let me just explain this to you. I'll just pause it and I'll just flick through it. Okay, so there's a sulfur dioxide gas, another gas that you need to be aware of. Okay, so you start off with two chemicals. One is called potassium dichromate, and the other is called sulfuric acid, right? And in order to get this reaction to take place faster, the sulfuric acid needs to be added to the potassium dichromate. Now, if you do that, you actually call that in chemistry acidified potassium dichromate. But it's the dichromate, the potassium dichromate, that is actually showing this chemical test, okay? So there's the spelling, potassium dichromate, okay? That 7 is just referring to the type of dichromate that you have, okay? Or the type of chromate that you have. Right. You notice it's like a yellow-orange color. Now, what's happening now is that in a second tube, this the scientist is adding something called sodium sulfite. Okay, now sodium sulfite is something that you can heat, and when you heat it, it actually makes this gas called sulfur dioxide. Okay, so in the test tube that she's got, it's colorless, it's just a colorless solution, and she's heating it, and it's just generating, it's just making a source of sulfur dioxide that we can then bubble into the potassium dichromate, the acidified potassium dichromate, to get a positive test, okay? All right, to get a positive test. Right, so let's have a look. So what she's done is she is heating the test tube in a very safe way using a test tube holder, and she's putting that in a blue Bunsen, and the gas that's being made is bubbling out of the colorless solution. It's moving up this glass tube, this L-shaped glass tube called a delivery tube. Now, sulfur dioxide is heavier than air, so it is perfectly okay to have it pointing downwards, and in her right hand, she's got the potassium dichromate. So when the gas bubbles through, you get the solution turning from orange to green. And that is the chemical test. That's the positive observation, right? So the chemical that you use is potassium dichromate. It should be acidified. So you use sulfuric acid with potassium dichromate. The observation that you see, if there's a positive observation, if you do have sulfur dioxide, is that you get a color change from orange to green. Okay? And that's it. That's what it looks like when you actually do it. She's got great control over her test tube. She looks like a very confident scientist there. It's a very quick test as well. Okay, and say bye.
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 Bye. Bye.
Bye.
Bye.
All right, take care, guys.
Bye.
See you. Bye.
Bye.
See you.
Bye.